Hello everyone. In this video tutorial, I will be taking care of a new sensor that is AD7999. And to get more knowledge about this sensor, let's have a look over the website that is controleverything.com. And here we have to search for this sensor. And as you can see, this is our sensor. It's a 4-channel 8, 12 or 10-bit analog to digital converter. And these are some of its more prominent features which you are able to see on my screen. And as a plus point, you can also purchase this sensor from here, right from here. For this video tutorial, I will be interfacing the analog to digital converter AD7999 using a BeagleBone Black, and the platform I will be using is the C code language. And to get that code, let's go to resource tab, and here comes the C code sample. Now you can download the C code sample as a source file from here. It's a zip file, as you can see, and also you can have the code from github.com, and the repository there is Control Everything Community. Now what we require is to have a look over some hardware connections we need to put up together. So let's have a look over that also. Well, for the hardware connection setup, the first thing we require is the BeagleBone Black, which you are able to see on my screen. And this here is an I2C Shield for the BeagleBone Black. Now this is available on the website controleverything.com, and the real reason we are using this shield is to make connections easier with other I2C devices. So for that, what we require is to gently place this I2C shield over the BeagleBone Black and make a connection just like that. For the power up setup, we require two things. The first is a mini USB cable just like this, and gently insert it over here. It is very useful to power up the BeagleBone Black. Now to power up the I2C Shield, we require a 5-volt adapter, which you are able to see on my screen, and gently insert it here. Now for an option for the internet connection, there are two mediums. The first is an Ethernet cable or a LAN cable, and the second is this, a wireless nano USB adapter. Now we require our sensor that is analog to digital converter AD7999, and this here is a connecting cable. Now make a connection among the sensor and the cable, and make sure that the brown wire of the cable should be connected to the ground terminal of the sensor, and same goes for the I2C Shield. So we are done with all the connections we need for this setup. Now let's have a look over the code and let's interface. Now coming to the interfacing section, first of all we have to log into github.com, and here we have to search for the repository that is Control Everything Community. And after that we have to get over, and here we have to search for this sensor AD7999, and let's see what we got here. And this here is the C code. But before moving to the code, let's have a look over the instructions we need to follow up. First of all, we need to set up our BeagleBone Black, and the required information for setup and all the procedures are provided on this very link, that is BeagleBone.org. And after that we have to download or git pull the code onto the BeagleBone Black, and to compile the C code, this is the command, and to run, this is the code. This is the command, as you can see. Note it down and keep it careful. And after that we have to get back to the C code. It's a .c extension file, and as you notice in the code, we have included some of the header files which need to be included. And in the void main function, first of all we have to create an I2C bus, and we have to check whether the bus is available or not. And after that we have to check for the I2C device of the sensor or the device. As you can see, it's 0x29. Then here comes the writing section part, where we are going to select first of all configuration command. As you can see, it's a channel 1 filter enabled, and it is 0x10. The writing command is here. Then we have a sleep of 1 second, and then we are going to read 2 bytes of data, which you can notice on my screen, the raw ADC MSB along with the LSB. Then we have the conversion of the data, which is according to the guidelines and the formulas provided in the data sheet for AD7999. At the very end of our code output, to be displayed as you can see onto the screen, it's the digital value of analog input. It's the raw value of what we are going to imply. Now this here is our code. It's a very generalized and simple code. Now what do we require next is to have a look over this practicality of this code, the working. Now let's have a look over the working part, and which is very interesting in itself. And for that, The first step is to copy this entire code of C language for the sensor AD7999, and after that we have to look upon the terminal for the BeagleBone Black, and here we have to create a new file. As you can see onto the screen, .c will be the extension of the file, and here we have to paste the entire code, and after that we have to save it. Now this is the command, as you can see on my screen. This is the command for the compilation, and we have to pull it to the terminal, and let's see what we got here. The code has been compiled successfully. After that, to build and to run the code, we have this command, as you can see onto the screen, and when I run or build the command, we have the digital value of analog input, which is 0, and when I run again and one more time, we have the same value, which means there is nothing connected among the terminal 1 and 0 of this particular sensor. But instead, when I bring a AA battery of 1.5 source voltage and I connect it, and when I run and build the command, we have the value of digital value of analog input, and its value of magnitude 43. When I run again and again, the same value is on to the screen, which means the battery is connected, and this is how the sensor responds. Now our main motive is to have a look over the applications and some of its more prominent features which will benefit us all. Now let's have a look over that. AD7999 is a 4-channel 8, 10, 12-bit analog to digital converter. As you can see, it's a low power successive approximation ADC with an I2C compatible interface. Each part operates from a single 2.7 volt to 5.5 volt power supply and features a 1 microsecond conversion time. Due to these features, it is applicable in a lot of applications like system monitoring, battery powered systems, data acquisition, and medical instruments. Well, you can have this sensor and you can purchase it from controleverything.com, and you can get the code from resource tab. From this site, you can download the code as zip file. Also, you can get the code from github.com, and the repository there is Control Everything Community. In the end, I would like to make it clear that if you have any doubt regarding any part of this sensor or video, you can have your queries on controleverything.com, and you can post your comments on the community page on this website. For articles and blogs, you can have a look over on instructables.com, and to subscribe more video tutorials like this, you can have a look over our YouTube channel. In the end, I hope you enjoyed this video and had a good one yourself. Thanks a lot for watching.